Course 3, Lesson 43, we are looking at surface area. So instead of filling something up, I want to wrap something, okay? And figuring out how much wrapping paper does it take to cover a solid. That's what surface area kind of looks like. So surface area is the combined area of the surfaces of the solid, and the lateral surface area is the combined area of the surfaces but not the bases. So we're going to take out the bases in this and just have what wraps it around. So if you can imagine a cylinder with those top and bottom bases, I'll take and put a picture up here. So we have our cylinder and these are our bases. Well, we're going to disclude those, so we're not going to include those in the total area, but we are going to include what wraps around that cylinder, almost like the label on a soup can. That's what we're looking for with lateral surface area, so not the bases. So to find surface area, we need to use nets sometimes. It helps us visualize. And one example of a net is right here. So we have all of these different pieces, and if we were to take this and fold it up, this would actually create a rectangular prism. You can imagine, okay, we have these four sides. These would be our lateral surface area. These are our bases, the green ones. Okay, we could assume some things about this. Green ones don't have to be the bases. Just know that with a rectangular prism, there's a lot of different possibilities. But we could find the surface area from this net. So we basically taken a solid and unfolded it to be what we have here. And we could figure out what the surface area is by finding the area of each of these pieces. And so the green, 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 by 6, all right, 8 by 6. And if that is 8, then this is 8. And then we need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 by 11, and we have by 6 again here. And we have all of our dimensions. So we can find the area of each of these parts. So we could say this is 48 and 48. We could say 88, 88, 66, and 66. And the question is, so we have all of these different dimensions, what do we do with them to get our final surface area? Well, we add them all together. And when we do that, we get 404. And what are our units? Well, we are talking about area. Even though it's surface area of a three-dimensional object, it's still area, so we are in units squared. We just have units times units, and we're adding them all up. So, kind of the questions that you're asking yourself through this, by using a net to find a surface area, what's the area of each rectangle? How do you know? Can you use the areas to find the surface area? Yes, we just add them all up. And we see that some of them are in common. We have 2 48s, 2 88s, 2 66, and that's because we have those similar sides on this rectangular prism. So using nets is very helpful to figure this out. So another example is right here. You can take some time to look at this and how we could have this rectangular prism. We could fold it up and find the surface area of each of these faces to add them up. Now we have another way to find the surface area. That other way, we are basically finding the area of each of the faces. And that will work with rectangular prisms. It'll work with any prism. But we do have another formula. And it's based on finding the area of the base and the perimeter of the base, and then using our height. So if we are saying that this is our base, this 5 by 6, the area of the base, big B, is 30 meters squared, and the perimeter, 5 plus 5, 6 plus 6, is 22 meters. And we use them in this formula to find the surface area of a prism. We say 2 times the area of the base. Okay, so we're covering this one and this base. And then we're finding the perimeter, all of these sides, times the height. And you can imagine, well, if I split that up, really I would just be doing 6 and 6 times the height. That's this side and this side. And then 5 by 5 times the height. So we're including all of the faces just in a little bit of a more concise definition. So we plug in 2 times 30, 22 times 7, and we add it up to get 214. Now remember, you do have another choice with rectangular prisms to say, I could say the surface area is 2 times length times width. Okay, so we could say 2 of length times width, so 5 times 6, plus 2 of width times height, so like 6 times 7 twice, and 2 of the length times the height. It gives us the same thing, but a little bit more concise when we do it, the 2 times the area of the base plus the perimeter times the height. So let's try this. We can say the base of this, it's sitting on that 7 by 7, so the area of the base is 49, and we're in yards squared. And the perimeter of the base, well, 7 plus 7 plus 7 plus 7 is 28 yards. So we plug it into our formula to say surface area is 2 times the area of the base plus the perimeter times the height. So we say 2 times 49 plus 28 times 2. Well, 2 times 49 is 98. 28 times 2 is 56. So we add them together to get 154 yards squared. Okay? And yes, you could find the area of each of those faces, add them up, that'll work. Okay, but we do have a more concise formula as well. Okay, I'll just do a couple more examples of this, not too many more. So if we do this one, we're going to say the area of the base is 40, and we're going to multiply that by 2, plus the perimeter of the base, so 10 and 10, so 20, plus 8, so 28, times 6. Well, 2 times 40 is 80. 28 times 6 is 168. Let me check that. 28 times 6. So we get 48, 12, and 4, 168. 168. We add those together with that 80. Get 8, 14, 248 meters squared is our surface area. We only are looking for a couple different things rather than finding our 3 different faces, multiplying them by 2. Now when we go to lateral surface area, what we are doing is we are excluding our base. So we're back to this one that we had before. And all we are looking at is perimeter times height. We don't need to add the 2 times the base because with lateral surface area, we are not including the bases. So we just need the height, which is 7, and the perimeter, which is 22. So we say the surface area is the perimeter times height, so 22 times 7, which is 154. 154 meters squared, and that's it. We don't have to add those bases in. So if we're looking at the lateral surface area of this one, we are just going to find that perimeter again, so that was 28, and multiply it by the height of 2, which gives us 56 yards squared. And we don't have to add those 249s in because we don't want them. We want the lateral surface area. And the lateral surface area of this one, we find that perimeter again, which is 28, multiply it by 6 again, and we got 168. 168 meters squared is going to be our lateral surface area. We don't have to add in that 80 because we don't want the bases. Okay, so find the total surface area of a cube with edges of 10 centimeters long. Well, if you think about a cube, all of those faces are going to be the same. So yes, we can plug it into our formula, or we can realize I really just need the area of the base times 6, which means 6 times 100 is going to give us our surface area of 600, and we are in centimeters squared. If we want our lateral surface area, really we only need 4 of those faces, and so I do 4 times 100, which is 400 centimeters squared. Okay, let's see. I'll show you a couple more examples. You can try these on your own. Finding the lateral surface area, I would encourage you to do the perimeter times the height here. Much easier, but it can be done other ways for sure. Estimate the surface area, so rounding before you find the surface area using 2 times the area of the base times the perimeter times the height. Okay, why would we need to know the surface area? Well, they're probably going to put a label or print something on there, so we need to know how big it is. Find the lateral surface area, perimeter times height. And a little bit of a harder one, find the lateral surface area of this building. Okay, for right now, let's just look at these side walls, okay? And you can find the lateral surface area using that perimeter times the height. Soon we'll be able to find the lateral surface area including those triangles as well. Well, I hope this is helpful for your homework and for studying.